Happy Friday, everyone. You guys are all doing well. Look at the return homework in a second. Before we look at that, does anyone have any general questions, comments, or needs about anything? Yes.
I wasn't here Wednesday, so I cannot turn mine in.
Yes, you can turn yours in. I might just need a little bit. I can get it for you at the end of the period.
No, that's fine.
Okay.
No, I don't have a meeting for this week.
Now you will. Okay. Additionally, while I'm thinking about it, make sure that your homework 4 looks like this, because last week I did upload an out-of-date document and then modified. This is the current 4th assignment. If it doesn't look like this, please let me know. Additionally, sort of a calendar out real quick. As a reminder, this homework number 4 is currently due next Wednesday. And my plan for that day is we will go over it in the class together and then grade it in class together so that you'll know how you did and you will have it to study for, because next week is when our first test is scheduled. I originally scheduled it for the Wednesday. I don't want to do that anymore because we have the homework due and I want to be able to spend Wednesday studying. So Wednesday, we will grade it together, study together, go over everything that will be on the test, which will then be next Friday. Any objections? Okay. If anyone has any particular needs or issues regarding that, do please let me know. I will absolutely work with you on academic accommodations. I just need to know about them. Now, any questions, comments, concerns, etc. about your homework 3? Overall, everyone did pretty well. Just be very careful going line by line in your algebra. Sometimes a negative sign might not get written. I made this mistake plenty of times. If you're writing and then you just don't translate the negative sign onto the next line, that can change things pretty substantially moving forward. So my main advice is just track that very carefully. Okay. While you're looking over it, if you have any questions at any time, do please let me know. If not, let's go ahead and keep moving forwards with number 4, so we can get through all of our lovely trig for today. And I'll get on to our weekend. We definitely don't want to keep you. So, we began looking at number 4 and reviewing our trig functions and our geometry functions. As a reminder, we went over so, ca, toa, and what every part of this acronym means. And we looked at sample triangle, labeling a few things, just as refreshers. So, did we find the answer for number 1? I think we did. Okay. Well, let's just finish that one off really quickly, and then we'll look at 2 and 3 together as well before talking about some additional concepts. So, let's say that we're doing number 1 together. So, for question number 1, I apologize for this inconsistency. Labels points A, B, and C because I prefer to label the lines instead. I tend to label lines, but this one, the question itself labels points. I apologize for the inconsistency there. I like personally to label the bottom leg A, the side leg C, sorry, side leg is B, and the hypotenuse is C. That's how I like to do it, and so I'll probably consistently do it. I apologize for the labeling in this picture. Now, in this physical situation, because number one is referencing a physical problem, a lot of your physics questions are going to give you the physical information. We then draw our picture as a representation and work from that. We are measuring, we're trying to estimate the height of a tree based on the length of its shadow and the angle of the sun creating that shadow. So in this question, we are given our angle of 15 degrees and a shadow length of 10 meters. So with this information, what is our best guess, our best first attempt at getting to the height of the tree, which the way that I've drawn it here would be side B. Very good. So SOHCAHTOA, we look at the TOA part, tangent of any angle equals opposite leg over adjacent leg. If we're doing tangent of this angle right here, because it's the one that we know, tangent of 15 degrees, it's going to equal the opposite side, that's the side that isn't touching it, divided by the adjacent side. The adjacent side is the side that is touching it, that isn't the hypotenuse. The angles, the two angles that aren't right angles will always touch the hypotenuse, so we need to look at the one that isn't the hypotenuse. So, tangent of our 15-degree angle should be equal to our B divided by 10. And from there, you simply have one or two lines of algebra to perform. First thing I recommend doing, figure out what tangent of 15 degrees is. Tangent is a function in your calculator. You press the tangent button and type in 15 degrees, press enter, it will give you an answer. But you need to make sure that you're in degrees mode if you plug in 15 degrees. For those who have not ever had to switch the mode of your calculator, like how we have feet and meters that measure the same thing, we also have degrees and radians that measure the same thing. And because they both come up very commonly, degrees and radians is just another version of measuring angles, they come up very often. Our calculators come pre-programmed to be able to handle both of them, but it can only do one of them at a time. If you put tangent of 15 into your calculator, and you get an answer of 0.2679 equals B over 10. That's the correct one. Did anyone not get that number? Okay. So that means that your calculator, and anyone else who didn't get this number, is currently in radians mode. So to switch it, on mine, you press literally the mode button. And on mine, the third option is the option to switch between radians and degrees. You go down and make sure that degrees is what is highlighted. You'll be in degrees mode. To briefly talk about radians, because they do come up later in homework, I'm going to draw a unit circle, which I know is everyone's favorite. So, in your previous math and geometry classes, you probably looked at the unit circle, and typically because of our x and y axes, we tend to start from here and begin rotating counterclockwise this way. We're going to mirror the same thing today. So looking at each of these axes, if we're starting here, how many degrees are we at? 0. Very good. So 0 degrees up here.
9.
Very good. Next.
180.
And next.
270.
360 is actually coming full circle. 270 is the 3/4 turn. You're always adding, in degrees, every quarter turn, you add 90 degrees. So 0 plus 90 is 90, 90 plus 90 is 180, 180 plus 90 is 720. So you've seen this before, you've measured degrees before. I'm putting this up here as a refresher of how they relate to radians. So 0 degrees equals 0 radians. 0 of anything should be 0 of the other unit too, except Celsius and Fahrenheit. Next, 90 degrees. This correlates to pi over 2 radians. I recommend you write this in your notes. You can also write this on the last page of your homework, which is the unit circle. So, wink, wink, nudge, nudge, start filling it.
I don't know how to memorize 10 times. We don't have to memorize that.
No, this is just to get you used to converting. Sorry? Sorry, I thought someone was asking a question. I'll go ahead and write the official conversion between degrees and radians is shown to us on the unit circle. So you can use this as a conversion. Any amount of degrees, you can divide by 90 and then multiply the answer by pi over 2 to get it in radians. So this statement can be used as a conversion to convert any radians to degrees or any degrees into radians. Now, 90 is pi over 2 radians. 180 should be how many radians?
Pi.
Very good. So the unit is radians. The number is pi. So it's 3.14 radians. Next, 3 over 2. Sorry, 3 pi over 2 radians. And lastly, 360 degrees equals 2 pi radians. So that's 4 of them for you for free. And I recommend highlighting this one in your notes because this is the most commonly used conversion from one system to the other. Maybe a couple inquisitive glances. Something wrong? Okay.
I'm just writing it down.
Okay. As you were writing, I'm going to go ahead and clarify one note about the assignment. You're asked to find 3 lines in the middle of each quadrant, just to add a little bit of clarity as to what each of these lines are. The middle one is 45 degrees. The one between, the first one you get when going counterclockwise is 30 degrees, and the one after 45 is 60 degrees. All of the quadrants have them in the middle at these intervals. So going from the y-axis counterclockwise into the third quadrant, you'll have one 30 degrees after that, 45 degrees, 60 degrees, and then you hit the next line. So just to help make sure the spacing is clear.
What are we supposed to put in the X, Y?
I was envisioning you just writing your two answers there. So one of them is the degrees answer, one is the radians answer.
Is there like a formula for that? Like, say for example, you had like 45 degrees, or is there like a number for every?
So, you mean a formula for the conversion?
Yeah.
The way that I convert, I do this for every single unit. If I have a statement like this, 360 degrees equals 2 pi radians, I can use that as the conversion factor after I use my phone. So what I would do is, if we were looking at 45 degrees, this is our starting statement. And I eventually want to get it into radians. So what I like to do is, I'm going to multiply this by the number 1. But it's going to be kind of a weird looking number 1. I would write 2 pi radians over 360 degrees. I know from this sentence here, those two numbers equal one another, meaning that one over the other should just be 1. So I'm multiplying by 1, meaning I'm not changing the value, I'm just swapping the unit. And orienting it like this, 2 pi rad over 360 degrees, cancels out the degrees and leaves me with radians. I do this for all of my conversions, whether or not it's radians, excuse me, degrees to radians, meters per second into miles per hour. I like this sort of a method where I set up, I call it kind of a railroad, because if it's more than just one fraction, I will draw it kind of like this. And I'm converting like multiple chains of events, and it kind of ends up looking like train tracks. And then the final answer comes out the other side. If you have a different method of converting, that is fine. This is just what I have done since time immemorial. If you have your own different method, that is okay. Just make sure it's written and you clearly, and you understand how to do it, and it is written clearly in all your work. But this is what I'm going to be putting on the board for conversion type stuff. Yes?
Can you work that out real quick?
Sure. So, what I would do in my physical calculator is, this is multiplication. We're multiplying 45 degrees by this fraction. So this is 45 degrees times 2 pi radians divided by 360. So what I would put into my calculator is 45 times, open parentheses, 2 pi divided by 360. And that would give me, the regular number that gives me is 0.785. And this number is in units of radians. I know all these statements up here have the symbol for pi in them. This already has pi worked into it. So the 3.14 is buried in that number. Yes?
So we have to switch our calculator over to radians, or unit degrees.
This math doesn't care about the mode.
Okay.
Only the sine, cosine, and tangent buttons care about the mode. This doesn't, because the calculator, if I just put this in the calculator, it doesn't know that I'm doing geometry. It just says, oh, numbers, boom.
Okay.
So if you were, oh, I'm sorry. I was just stretching.
Okay.
So if you were putting it into degrees from radians, you would just flip the fraction?
Correct.
Okay.
And since this fraction equals 1, you can do it either direction, just depending on what you want. That's allowed.
Okay.
And if you wanted to, if you divided this number by pi, that would give you 0.25, which tells us that we could rewrite this as 0.25 pi radians, or pi over 4 radians, which makes sense because 45 degrees is halfway between 0 and 90. So pi over 4 is halfway between 0 and pi over 2.
That was my question.
Yeah. So you can do this either by converting or by simply dividing up. Pi over 2 cut in half would be pi over 4. That would be a little more effort to find. So this would be pi 2. Pi over 6, and then pi over 3, I think. So that is our brief that's a pun, isn't it? Our brief tangent into the unit circle. So finish filling that in on your homework, and while working your homework, make sure you know what mode your calculator is in. I prefer degrees mode because I just am used to thinking in degrees. So mine tends to stay in degrees most of the time. Just double check though when you're working your answers. If you put in degrees, check it's in degrees. This is the correct degrees answer for right now. Back to problem 1. So if we're going to multiply both sides by 10, that should tell us that this tree is 2.679 meters tall. Which, if you recall, that 1 meter is about 3.3 feet. It's pretty tall, actually. Just for compared to a human. Where's the sheet that I was working on? I set things down and I forget what I did with them. It's a chronic problem. No, this was it. I just put it on top of the file. Okay, so that is number 1 completely worked. Number 2 is very similar. It's almost the same problem, except that there's you're going to be required to go find some of the numbers yourself. And you can work together on this. The thing that you're going to be measuring the height of for number 2 is the pillars do they still call it Bluehenge? Okay. The pillars next to Smith look kind of Stonehenge-y. You guys know what I'm talking about?
Aluminum green.
That big, yes. It was freshly built when I was first a student here, and at the time, and apparently my other coworkers still call it Bluehenge. But yes, the pillars on the alumni green. Your task is going to be to go collect numbers yourself on a day of your choosing. It doesn't have to be today. I don't know, it could be today because it's overcast and raining. Measure the shadow of one of the pillars and the angle between the ground and the sunlight. That can be a rough approximation. You don't need to be super precise measuring sun angle. Please don't burn your eyes out looking at the sun. I'm grading for correct algebra and consistency on the answers. You don't have to get an exact answer. But you do exactly the same math, just someday between now and Wednesday. Have a nice walk to the green and measure the sun.
It's supposed to rain like all week.
It is?
Yeah.
Well,
Until like next Friday, I think.
Let's go take a trip up there right
right now I need to get through the rest of the homework all the way to secant, cosecant, cotangent. If it does keep storming all week, I will email out some sample measurements. How about that? Okay.
now. What about the big tree out there?
And that would work too, as long as there's sunlight enough to measure it. I don't like doing trees for this because like the shadow of the top of a tree is only, what is the top of the tree? Is it the top of the wood? Is it the top of the leaves? And what part of the top of the leaves cast what part of the shadow down there.
But wouldn't it just be
It's
like
always
the place
moving in
furthest?
negative space. Sorry?
Wouldn't it just be the place furthest from the tree? The furthest, like, part of the shadow from the tree?
That makes the most sense. I just always feel like I always feel unscientific about it. I always feel like I'm guessing.
Yeah.
At some point this week, if the sun is out, measure something. It can be the tree.
What if we did paces?
Okay, paces is fine too.
Pieces?
Yeah,
Yeah, just like the
One.
one foot in front of the other.
2, 3.
It's just consistency.
It's not on the phone.
Just make it clear what thing you measure and what your unit is. If you use paces, just make sure it's in units of paces. In which case, no one's answer will be the same thing, because no one has the same foot size or gait. And again, if the sun just doesn't come out this week, I'll give you some sample measurements. Let's look at number 3 now. 3 is a bit of a fill in the blank, and we're going to use that to review other trig tricks that you will need for the bulk of this assignment. Or that will just be handy, period. So, numbers 3 through 6 give you triangles, and your job is to fill in every side and every angle of those triangles. And each question will give you various parts of each one. Number 3 says the lower left angle is 57 degrees. So this is lower left, that angle is given to us. Additionally, these are 3 through 6 are all going to be right triangles. So another one of those angles is always a given. So the right angle is going to be this bottom right one here. We're also told that the bottom leg is 5 inches. So that will be this one right here. So for this whole triangle, we know 2 angles and 1 side. Yes?
Can you go ahead and put the third angle too?
Yes, we can use a couple of tricks to go ahead and assume what that third angle is.
32.
Very good. So the simplest way to find the third angle on any triangle. So trick 1. All angles on a triangle add up to 180. On any triangle, if you know 2 of the angles, you can figure out the last one. So if you want a formula to write in your notes, I would say angle 1 plus angle 2 plus angle 3 equals 180 degrees without fail on any triangle, as long as it has 3 sides. So for this case, we know 57 and 90. We want the third one. They have to add up to 180. We subtract the other 2 from 180, figure out the last angle. Yes?
I mean, like, obviously they look like right angles, but I just want to make sure all of these, they have right angles on them, right? Except for the ones on like the next few pages.
Yes, 3 through 6 are all right triangles, and the leg the angle that looks like a right angle is the right angle.
Okay.
7 and 8, I'll show you how to divide up momentarily. So, this is easily the common, shortest way to find any angle in a triangle. This would give us an angle, right there at Q. Angle 3 for this particular triangle equals, you said 33 a moment ago. And that is the missing angle for this triangle. There's another way you can find angles, though. Say we didn't know any of the angles except the right angle. So, for example, before we talk about the next tactic, let's actually find one of these sides first. What side do you guys like? We have the hypotenuse and the tall side. You know what, we're gonna do the tall side because hypotenuse is gonna come like that right in 0. Sorry to invalidate the fact that I asked your opinions, but I apologize, I try not to do that. Okay, so this is how we found our first angle. We're now going to use our angle and this side to find this side. So, if this is the angle we're working from, 57, B is the opposite in relation to that, and 5 inches is the adjacent. So we're going to go back to our friend tangent. Tangent of, 57 degrees this time. I almost wrote 15 again. Equals our B side over 5. If memory serves, our B side should come out to about 7.7 inches. So go ahead and label that up here. Now, let's say hypothetically, we knew 5 inches and 7.7 inches, but we didn't know this angle. How could we go about finding that angle?
The angle, wait, the angle or the side?
The angle. If we didn't know this angle, but we did know the sides, what could we do? Very good. So, trick 2 is remember how to do inverse trig, which I'll put up on the board. And this is mostly a review of how to find the inverse, or to get inverse trig functions loaded. So if we were hypothetically didn't know that angle, but we did know those two sides, tangent of unknown angle would be the opposite leg over the adjacent leg. The way to get to theta equals blank is to employ inverse trigonometry. We have to undo the tangent, like how you would undo a square root with a square.
Is it the 10 to the -1?
It is. It is literally inverse tangent. So tangent is an operator that acts on theta. Inverse tangent is also an operator. So we can apply that operator to both sides. Tan inverse applied to tangent of theta equals tan inverse of 7.7 over 5. So if you apply inverse tangent to both sides, inverse tangent of a tangent just breaks down, and that frees the theta. So that just leaves us with theta equals inverse tangent of 7.7 over 5. All three of the trig functions we've already used have an inverse function. On my calculator, the inverse function is the secondary function of the same button. So my sine button has inverse sine right above it. All of them have an inverse. All of them can be broken down by applying the inverse to them. And doing this, actually putting inverse tangent in my calculator really quickly. Inverse tangent of 7.7 over 5 gives me 57 degrees. So, we figured out all the angles. You have 2 of the 3 sides. Last piece of review for this part of the assignment, which should very much be review. If you have 2 of 3 sides of a right triangle, that's the classic way to find the third one. Very good. Which, as always, looks like this. Which, between A, B, and C, which one is picky about what leg goes there?
C.
Very good. C always has to be the hypotenuse. I will always consistently label the hypotenuse as C in my drawings. When using the Pythagorean theorem, just take care with the squares followed by the additions. If we were doing it for this triangle to find the hypotenuse, 5 squared plus 7.7 squared equals C squared. Make sure the calculator is effectively doing this operator, then adding them, then taking the square root. It should be able to do that without much hiccups, but I don't trust the machines, frankly. So if I was to write down how I would try to put this whole thing into the calculator as one line, I would do square root, open bracket, 5 squared, close bracket, plus, open bracket, 7.7 squared, close bracket, close bracket. Why am I stepping on letters? And what would make that, what then is the hypotenuse of this triangle? 9.8?
9.2.
9.2, thank you, sorry. My ears don't work so good. And units are inches. As a general rule, hypotenuse is always the longest side. So if you somehow plug two numbers into this and your hypotenuse is smaller, that's an invitation to check your math. Now, 3 through 6 are all variations of this. And you can use any combination of these steps you want. If for some reason you just hate the Pythagorean theorem, you can set it up to where you never have to use it. Because as long as we know the other sides and the other angles, we can use trig to find the hypotenuse instead. So any combination of SOHCAHTOA and these tips can get you to the answer. If there's one you just hate, you never have to do it. I'll usually mix my methods up depending on what I think is fastest. I would say this is probably the simplest trick though, so do keep that one in your head. And the rest of the first page is all very much the same. I want to make sure to show you guys a couple of things on the second page before we break. There's 3 different sections on page 2. 3 if we lump 7 through 9 in together. I'm going to erase the unit circle real quick. Nine is another right triangle problem. It gives you all the sides and you just need to find the angles. 7 and 8 are a little bit trickier because those don't begin life as right triangles. I'm going to give a rough sketch of those real quick. 7, we have this, and 8, we have this. That's not a right leg. These aren't right triangles. Every single thing we've already done doesn't work here. We are told a couple of things about each of these triangles. For 7, bottom leg is 8 centimeters. Top left leg is 6. And the left angle is 31. For number 8, we are told the bottom right side is 6.32 feet. The top right angle is 18.43 degrees, and the left angle is 45 degrees. So we're told 3 things about each one, and none of them are right triangles. Yet. Because any triangle can be ripped in half to make two right triangles. So what I would do for each of these is tear this one straight down the center. And we get two right triangles. And tear this one like so. That does mean, for 7, that this 8 has now been divided up unevenly between these two legs, and the problem does not immediately tell you how much, how long each piece is. So now that we have our right triangles, we can begin performing all of our various trig and geo steps on all of them. For 7, what I would specifically do is, we know this angle and this side and this angle. If you figure out what this side is, this piece of the leftmost triangle, say it comes out to 5. If this chunk is 5 and the whole bottom line is 8, what would that make this? Very good. So that will tell you automatically at least one part of this other triangle.
Wait, what did you say? I'm sorry, I missed.
It's okay. So say we're looking at the left triangle that we made here. And we solve for the bottom leg of that triangle. If it came out to 5, we know that this piece plus this piece need to add up to 8.
Okay.
So that would make this piece 3. That's not the literal measurement, that's just the sample measurement. I think 8 is a little more straightforward because we already have one whole side. And keep in mind, both of these triangles will have a common side. So you find that this length on one side is the same on the other. And the last thing I want to make sure you see before we break it. This upper rightmost section on page 2 asks you to use the different trig operators on specific parts and angles of the triangle in number 9. 3 of those operators are sine, cosine, tangent, and you apply them to a specific angle in number 9. There's 3 more operators listed there, though. Who has never seen cotangent, secant, and cosecant? You guys seen them before? Okay. That said, to at least refresh memories as to how they relate to the previous ones, it's cosecant and sine. I myself need a refresher every single time because I can never remember between sine and cosine and secant and cosecant which ones relate to each other. But it is sine and cosecant. Okay, so sine of theta equals opposite over hypotenuse. Cosecant theta equals hypotenuse over opposite. Next, cosine of theta is adjacent over hypotenuse. Secant theta is hypotenuse over adjacent. Then tangent theta is opposite over adjacent. Cotangent of theta is adjacent over opposite. So the 3 weird ones that don't have calculator functions are just the literal inverses of the other three. And an additional relationship, sine theta is equal to 1 over cosecant theta. Furthermore, cosine theta is 1 over secant theta, and tan theta is 1 over cotangent theta. I always have to look those up every single time, so there they are. With that, that is every piece of information that you should need to be able to complete the assignment. On Wednesday, I'll answer any questions about the assignment. We will grade it together once everyone is comfortable with it, and then we will make sure everyone is on equal footing for what is going to be on the test for next Friday. Not next Wednesday, it's next Friday. We'll have time to grade and study together. Does anyone have any questions about anything at all, this assignment or the upcoming test, before we grade? Okay. If you have any while working the assessment or while studying, please let me know, email me, come find me in my office. And you have a wonderful weekend. It's been warmer out recently, so stay dry, because apparently it's going to clean all week. Again, my yard is already just mud. I don't even